Download this code from codegive.com, link in the description below. OK, let's dive deep into Content Security Policy, CSP. This tutorial will provide a comprehensive introduction to CSP, explain its purpose, how it works, and demonstrate practical examples with code snippets. What is Content Security Policy, CSP? Content Security Policy, CSP, is a security standard introduced to prevent various types of web-based attacks, most notably cross-site scripting, XSS. It's an added layer of security that helps to detect and mitigate certain types of attacks, including cross-site scripting. XSS attackers inject malicious scripts into websites viewed by other users. Clickjacking. Trick users into clicking something different from what they perceive. Data injection attacks. Malicious code is injected to modify the data of an application. Package sniffing attacks. Intercepting and inspecting data packets. CSP essentially instructs the browser on which sources of content, scripts, style sheets, images, etc., it should trust and load. Any attempt to load resources from untrusted sources will be blocked by the browser. Why is CSP important? Traditional web application security focuses on validating user input and encoding output to prevent attacks like XSS. While these techniques are essential, they are not foolproof. CSP offers a defense-in-depth approach by adding a browser-side mechanism to prevent malicious code from executing, even if vulnerabilities exist in your application's code. How CSP works? CSP works by defining a set of rules, directives, within an HTTP response header or a meta tag. These rules tell the browser which sources are allowed for different types of content. When the browser receives a page with a CSP policy, it checks every resource, scripts, style sheets, images, etc., against the policy. If a resource violates the policy, the browser blocks it and, usually, reports the violation in the browser's developer console. CSP directives, the building blocks. CSP policies are made up of directives. Each directive controls what sources are considered valid for a specific type of resource. Here are some of the most common and important directives. Default SRC, this is the fallback directive. If a directive for a specific resource type is not defined, the default SRC is used. It's a good starting point to restrict all sources to only trusted ones. Script SRC defines the valid sources for JavaScript execution. This is a crucial directive for mitigating XSS attacks. Style SRC defines the valid sources for style sheets. IMG SRC defines the valid sources for images. Connect SRC defines the valid sources for network requests, AJAX, WebSockets, etc. Font SRC defines the valid sources for fonts. Media SRC defines the valid sources for audio and video. Object SRC defines the valid sources for plugins, example Flash. This is typically best set to none unless absolutely required. Frame SRC defines the valid sources for frame and iframe elements. Use frame ancestors instead if possible, more modern. Frame ancestors specifies valid parents that may embed a page using frame, iframe, object, embed, or applet. To indicate that the document may not be framed at all, you can use frame ancestors none. Base URI specifies allowed URLs that can be used to specify a base URL. If not set, any URL is allowed. Form action specifies valid endpoints for form submissions. Asterisk report URI specifies a URL where the browser should send reports about CSP violations. Deprecated in favor of report to. Asterisk report to specifies a group name defined in the report to header to which CSP violation reports should be sent. Asterisk upgrade insecure requests instructs the browser to treat all of the site's insecure URLs, HTTP, as though they have been replaced with secure URLs, HTTPS. This directive is essential for transitioning a website to HTTPS. Asterisk requires SRI forces the use of sub-resource integrity, SRI, for scripts or styles. Asterisk sandbox enables a sandbox for the requested resource similar to the frame elements sandbox attribute. Asterisk worker SRC specifies valid sources for worker, shared worker, or service worker scripts. Source list values. Directives are followed by a source list, which specifies the allowed origins, keywords, or data schemes. Here are some common source list values. Asterisk matches any origin, use with caution. Generally avoid this, especially for script and style sources. Asterisk self matches the origin of the document, same scheme, host, and port. Asterisk none blocks the resource type completely. Asterisk unsafe inline allows inline JavaScript and CSS, example script tags directly in the HTML or style attributes. Generally avoid this, as it defeats the purpose of CSP and makes you vulnerable to XSS. Asterisk unsafe eval allows the use of eval and similar functions, example new function. Avoid this if possible, as it can be a security risk. Asterisk unsafe hashes allow specific inline event handlers using their SHA-256, SHA-384, or SHA-512 hash. Avoid this if possible. Asterisk strict dynamic allows scripts loaded by trusted scripts to load other scripts. This is often used with nonces or hashes. Asterisk nonce-random value allows inline scripts that have a matching nonce attribute. A nonce is a cryptographically random, single-use token. Asterisk SHA-256-hash value, SHA-384-hash value, SHA-512-hash value, allows inline scripts that have a matching SHA hash. You can generate these hashes using various online tools or command line utilities, example OpenSL. Asterisk data allows the use of data URLs, example for embedding images directly in the HTML. Be careful with this, as it can be a potential attack vector. Asterisk media stream allows media stream scheme to be used as a source. Asterisk blob allows blob scheme to be used as a source. Asterisk file system allows file system scheme to be used as a source. Asterisk https://example.com allows resources from a specific origin, including the protocol. Asterisk star.example.com allows resources from any subdomain of example.com. Setting CSP, HTTP header versus meta tag. You can set CSP using either an HTTP response header or a meta tag in the HTML. The HTTP header is generally preferred because it is more secure. Asterisk HTTP response header asterisk send the content security policy header with your server's response. For example, asterisk meta tag asterisk use the meta tag in the head of your HTML document. Important asterisk using the meta tag has some limitations. It cannot be used to set the frame ancestors, report URI, sandbox, or upgrade insecure requests directives. Therefore, using the HTTP header is highly recommended. Report URI and report to directives, monitoring violations. CSP provides the report URI and report to directives to send violation reports to a specified endpoint. This is crucial for monitoring your CSP policy and identifying areas that need adjustment. When a CSP violation occurs, the browser sends a JSON report to the URL specified in report URI. The report to directive allows more flexible and complex reporting configurations by using the report to header, which specifies a reporting group. Example of a violation report, JSON. The blocked URI field indicates the resource that was blocked, and the violated directive field indicates the directive that was violated. You can use this information to adjust your CSP policy or identify potential security issues. Using report to directive asterisk. First, configure a report to header. The report to header defines a reporting group named CSP endpoint. Max_age specifies how long the browser should cache this configuration. Endpoints is an array of URLs where the browser should send reports. The report to directive in the CSP policy then references this reporting group. CSP in report-only mode. CSP also has a report-only mode, which allows you to test your CSP policy without actually blocking any resources. This is very useful for initially implementing CSP and making sure that it doesn't break your website. To use report-only mode, use the Content Security Policy report-only header instead of Content Security Policy. In report-only mode, the browser will still report CSP violations, but it won't block the resources. This allows you to see what would be blocked if the policy were enforced, and you can adjust the policy accordingly. Practical examples and code. Let's look at some practical examples of how to use CSP in different scenarios. 1. Basic CSP policy ***. This policy only allows resources from the same origin, self. This policy will block all external scripts, style sheets, images, etc. This is a good starting point to see what you need to allow. 2. Allowing scripts from a specific domain ***. This policy allows scripts from the same origin and from https://cdn.example.com. 3. Allowing style sheets from a specific domain ***. This policy allows style sheets from the same origin and from https://fonts.googleapis.com. 4. Allowing images from any domain ***. This policy allows images from any domain, ***. Use this with caution, as it can be a security risk if you don't trust the sources of your images. 5. Using nonces for inline scripts ***. This is the preferred method for allowing inline scripts. It involves generating a random nonce value and adding it to both the CSP policy and the script tag. Generate a random nonce ***. This example uses Python, but you can use any language to generate a random string. Set the CSP header ***. Replace nonce with the actual nonce value you generated. Add the nonce to the script tag ***. Replace nonce with the same nonce value you used in the CSP header. 6. Using hashes for inline scripts, less recommended. This involves calculating the SHA hash of your inline script and adding it to the CSP policy. This is less flexible than using nonces because you need to update the hash every time you change the script. Calculate the SHA hash ***. This command will output the SHA-256 hash of the script. Set the CSP header ***. Replace your _hash _ here with the actual SHA-256 hash you calculated. Add the inline script ***. 7. Disabling inline styles and scripts ***. This policy disables inline styles, example div style equals, and inline scripts, example script, /script, entirely. You'll need to move your styles to external style sheets and use external JavaScript files, or use nonces or hashes. 8. Upgrade insecure requests directive. This directive tells the browser to automatically upgrade all insecure HTTP requests to HTTPS. This is essential for transitioning a website to HTTPS. 9. Require srefor directive. This directive forces the use of sub-resource integrity, SRI, for scripts and styles. SRI allows the browser to verify that the files it downloads from a CDN haven't been tampered with. Implementing CSP, step by step. Here's a suggested process for implementing CSP. 1. Start with a lenient policy *. Begin with a very restrictive policy that blocks everything except resources from your own origin, default src self. 2. Use report-only mode *. Deploy the policy using content security policy report-only and configure a report URI or report to collect violation reports. 3. Analyze violation reports *. Carefully examine the reports to identify which resources are being blocked. 4. Adjust the policy *. Gradually add exceptions to the policy to allow legitimate resources, such as CDNs, external fonts, or embedded content. Use specific origins whenever possible, and avoid using wildcards, * unless absolutely necessary. 5. Test thoroughly * after each change. Test your website to ensure that it still works as expected. 6. Enforce the policy * once you're confident that the policy is correct, switch to using the content security policy header to enforce the policy. 7. Monitor regularly * continue to monitor the violation reports to identify any new issues or potential security problems. Best practices and considerations. * Start with a restrictive policy and gradually loosen it *. It's easier to add exceptions than to remove them. * Use specific origins instead of wildcards. * Avoid using * unless absolutely necessary. * Use nonces or hashes for inline scripts and styles. * Avoid using unsafe inline. * Avoid using unsafe eval. * If you need to use eval, consider alternatives. * Monitor your CSP policy. * Use report URI or report to collect violation reports and adjust your policy as needed. * Keep your CSP policy up to date. * As your website changes, your CSP policy may need to be updated. * Consider using a CSP generator. * There are several online tools that can help you generate a CSP policy. However, be sure to review the generated policy carefully before deploying it. * Test your CSP policy in different browsers. * CSP support can vary between browsers. * Educate your team. * Make sure that your developers and other team members understand how CSP works and why it's important. * Use sub-resource integrity, SRI when using CDNs. Use SRI to verify that the files you download haven't been tampered with. Common mistakes to avoid. * Using unsafe inline or unsafe eval. * These directives significantly weaken CSP and make you vulnerable to XSS attacks. * Using wildcards too liberally. * Avoid using * in script src or style src directives. * Not monitoring CSP violations. * If you don't monitor your CSP policy, you won't know if it's blocking legitimate resources or if there are potential security problems. * Deploying a CSP policy without testing it. * This can break your website. * Assuming that CSP is a silver bullet. * CSP is a valuable security tool, but it's not a replacement for other security measures, such as input validation and output encoding. Conclusion. Content security policy is a powerful tool that can significantly improve the security of your web applications. By carefully defining a CSP policy, you can protect your users from XSS attacks and other security threats. Remember to start with a restrictive policy, monitor your CSP policy, and keep it up to date. Implementing CSP can be challenging, but the benefits are well worth the effort. Good luck.